Hello, everybody. This is 1.03 Algebra 2 notes. So 1.03 Algebra 2 notes. We're going to talk today about factoring higher degree polynomials. Factoring higher degree polynomials. All right, so what that means is the lead term is going to have an exponent that's greater than 2. So the first one we want to factor is x to the 4th plus 8x squared plus 12. All right, so it's the same idea here. Since there's a 1 in front of the x to the 4th, that lead term, the lead coefficient is a 1, then you're going to use guess and check. If it's bigger than a 1, that's when you're going to use P's and C's. Same rules apply. So this is a 1, so we're going to go straight to guess and check. So instead of, since it's x to the 4th, we need x squared times x squared to give us x to the 4th. We're still going to look to our last number here, which is a 12, and we want to know what two numbers multiply to 12 and combine to 8. If you don't know the answer to that, go to your calculator, go to your Y1, type in your last number, which is 12 divided by x, and take a look at your factors in the table. And hopefully you see that a 6 and a 2 multiplies to 12 and also add to 8. We want them to have the same sign since the 12 is positive, and it's a positive 8 in the middle, so they're both going to be positive. And then you always want to check to see, can you factor any further? So do you have any difference of two squares? And we don't in this case, so we are done with that one. Next one we want to factor is y to the 8th minus 81x squared. So this is considered a higher degree polynomial because they have y to the 8th for this one. Notice it's only 2 terms. So when it's 2 terms, again, you always start by looking for your GCF, whether it's 2 or 3 terms. There's no GCF here. And if it's only 2 terms, then we're going to look to see if they are both perfect squares. And in this case, they are. So we're going to be able to use dots because we've got, these are, last time we talked about any even exponent is a perfect square. So 8 is even, perfect square. 2 is even, that's a perfect square. So we'll use dots, and you might want to write a note to yourself here too. Even exponents are always perfect squares. All right, so we'll do our 2 sets of parentheses. The first, whatever the first term is, that's going to go in our first 2 slots. So the square root of y to the 8th. So remember, when you are taking the square root of an even exponent, you're just dividing it by 2. So 8 divided by 2 is 4. So y to the 4th times y to the 4th gives you y to the 8th. Why does that work? Well, when you multiply with the same base, you keep the base and you add the exponents. That's why you're just dividing it by 2. So 4 plus 4 would give you 8. And then 81x squared, the square root of that is going to be 9x. That'll go in your last 2 spots. The first one's positive, the second one's negative. And we look to see, are there any still perfect squares? And there is not. It's close. So if this had been y to the 4th minus 9x squared, then we could take it a step further. But since it's just 9x, this x is not a perfect square, so we can't take that any further. All right, next one, the directions are to factor completely. And the polynomial is 7x to the 4th minus 4x squared minus 3. So first thing we always want to do is look for our GCF. Especially when it says factor completely, because that usually means there's more than one step. So look at my 7 by 4 and my 3. No GCF there. And 3 doesn't have an x, so I can't take any variable out from all 3 either. So let's see if we can factor this. I look at my lead coefficient and it's a 7. So since it is greater than 1, I'm going to use P's and C's. So P's and C's is going to be the same as we did last class, except when we write it out as our 4 terms, you're going to do blank x squared, because that's your middle term is x squared, blank x squared, instead of just doing blank x. I don't know if you guys can hear Suki crying. Suki is my dog. And next we're going to find our P and our C. So P is the product of your first and last term. So 7 times -3 gives us -21. And C, our center term you're taking from this original, is -4. So again, if you need help, go to your y equals, type in -21 divided by x, and look for your factors. We know they want to have different signs, and they want to add to a -4, so that looks like it should be -7 and +4. So now I'm going to take those two numbers and fill them in on here. Oh, sorry, that should not +4. We want -7 and +3. Because -7 plus 3 would give us -4, -7 times 3 would give us -21. All right, and now we'll put the -7. It doesn't matter which slot you put them in. It'll work out either way. Group our first two and our last two pairs. I'm going to jump down to here. Factor out my GCF. So my GCF in terms of numbers, out of 7 and 7, I could take out a 7. I want to take out a +7 because this first 7 right here, whatever the first term is, the first term is positive, you want to take out a positive. And then they both have at least an x squared. So you're always looking for the smallest exponent. And then I'm going to divide both by 7x squared. Inside the parentheses, I write what's left. 7's cancel. X to the 4th divided by x to the 2nd is x to the 2nd. Remember, you subtract exponents when you're dividing them. Here our 7's cancel, our x squareds cancel. So do I just not write anything? No, because if you have 2 terms here, you still have to have 2 terms here. And when you divide something by itself, it gives you 1, not 0. Now here I'm looking at for my GCF. I have a +3 here and a -3 here. So I can take out a 3 from both of those. Since the first term in this set of parentheses is positive, I'm going to take out a +3. So I'm dividing each of these by 3. Since this one doesn't have an x, I can't take an x out from both. So this leaves me now with x squared minus 3 divided by 3. They cancel, giving us a 1, not a 0. We're in luck because our parentheses match, so we're going to factor that out and write that only 1 time. And then your leftovers go in your other set of parentheses. Now, we look at that and we say, oh, can we factor any of these further? And the answer is yes. Right here, you have dots. Difference of 2 squares. X squared is a perfect square, 1's a perfect square, and it's subtraction, so it's a difference. So I could factor that as x minus 1 and x plus 1. And then don't forget to bring down this binomial still. 7x squared plus 3. Now check, can I factor any of these further? And the answer is no. So that would be our final answer. All right, the next one is we're going to factor completely again, but this time we're going to solve. So this is number 4. Factor completely and solve. So we've got 2x to the 6th plus 30x squared equals 16x to the 4th. All right, so whenever we're solving, just like last class, you want to always have your highest exponent. So before it was an x squared. In this case, it's x to the 6th. So you want that to be positive, which it is, and you want to get it equal to 0. So I'm going to subtract this 16x to the 4th over to here. Standard form means we want to have them in descending order. So I'll have here 2x to the 6th minus 16x to the 4th plus 30x squared equals 0. First thing you always check for, especially, it's always, but factor completely usually tells us that we might have a GCF. So double check there. I look at all my numbers, 2, 16, and 30, and I can take out a 2 from all of those. And then I look at my variables, x to the 6th, x to the 4th, x to the 2nd, and I can take out an x to the 2nd from all of those. So now I'm going to go up here and I'm going to divide each of these by that GCF of 2x squared. And then inside my parentheses, I'll write what's left. So my 2's cancel. X to the 6th divided by x to the 2nd. Keep the base, subtract the exponents, leaves me with x to the 4th. Negative 16 over 2 is negative 8. Again, subtract your exponents. I get x to the 2nd. And 30 divided by 2 is 15. And my x squareds cancel out. Now I want to try to factor this. This one has a 1 as our lead coefficient. So we do not need to use P's and C's. You can. P's and C's will work even when guess and check does, but it's usually a little faster to do guess and check. So I'm going to bring down my 2x squared, set up my 2 sets of parentheses for guess and check. And since the middle term is x squared, and I want them to multiply to x to the 4th, I'm going to put an x squared in the first 2 slots. I need 2 numbers that are going to multiply to 15 and combine to negative 8. So again, you can go to your y equals, type in y1 equals 15 over x, or you might be able to do this one in your head. Say, well, I know 5 times 3 gives me 15. I want them to have the same sign, and I want them to add to a negative 8, so they're both going to be negative. And then we look to see, can we factor any of these further? Well, no, because 5 and 3 are not perfect squares. So that's as far as we can take it. So now we're going to draw a line between each factor and set each of them equal to 0. Again, this is a very important step that you must show. So show me that each factor is equal to 0, then go through and solve. So divide by 2, 0 divided by anything is 0. So we have x squared equals 0, the square root of 0. And you always put a plus or minus there, but with 0, it doesn't have a sign, so it would just be 0. Here we're going to add over our 5 and then take the square root of each side to get x by itself. Whenever you take the square root, you must remember your plus or minus, so we get positive or negative rad 5. Here we're going to add over the 3, take the square root of each side to solve for x. Again, whenever you take the square root of both sides, you have to remember your plus or minus. So we have actually 5 answers here. We have x could be 0. It could be positive or negative rad 3, and it could be positive or negative rad 5 for that one. Okay, so that's if you factor completely and solve. Okay, next up we're going to do 2 that are factoring by grouping. Factor by grouping. So this is kind of like the end of P's and C's for this one. So letter A will be our first one. 3x to the 3rd plus 2x squared minus 27x minus 18. Notice this is 4 terms, not our usual 3. So we're going to kind of use the end of P's and C's here, where we've expanded it into 4 terms. So we're going to group our first 2 terms, group our last 2, and take out a GCF of our first 2. So I'm looking at the numbers 3 and 2. I can't take a GCF out of 3 and 2, only a 1. And then I look at my variables, x to the 3rd and x to the 2nd. Well, they both have at least an x to the 2nd, so I can take that. So I'm going to divide each by x to the 2nd, leaving me with 3x plus 2. Here I have a negative 27 and a negative 18. So I see that I can take a 9. Since the first term in this set of parentheses is negative 27, I'm going to take a negative 9 out and divide each by negative 9, leaving me with positive 3x. Negative 18 divided by negative 9 is positive 2. Our 2 sets of parentheses match. That's good. So we're going to rewrite that one only once. And then our leftovers go in the second set, x squared minus 9. Can we factor any of these further? Yes, we can. So right here we have dots. x squared minus 9. So 3x plus 2, nothing to take that further. It's a linear 3x. So we keep that, and then x squared minus 9, we can split into x plus 3 and x minus 3. And none of those we can take any further. So that's as far as we can go. All right, and then we'll do letter B. So B is a little bit longer. K to the 4th minus 4k squared plus 8k to the 3rd minus 32k plus 12k squared minus 48. Notice this has been rearranged to kind of help you, but they could give this to you and you could have to rearrange it on your own so that it works out nicely. All right, we're gonna group by 2's here. So the first 2, the second 2, and the last 2. I'd like you guys to pause right here and then do the same thing we did before. So factor out your GCF from each of these 3, and then see if the parentheses match after that and regroup. Okay, so hopefully you saw that you could take out your k squared. I'm just gonna go through it really quick just so you can see. Hopefully you've already have this done on your own. And you'll see that you have all 3 of these parentheses are the same, so we're gonna rewrite that only once. And all your leftovers, so you'll have 3 terms, are gonna go into their own set. So k squared plus 8k plus 12. Now we always want to see if we can factor further. So I notice here, k squared minus 4, that's dots. That's a difference of 2 squares. So I can factor that as k minus 2 and k plus 2. And this, I notice I can also factor because I know there are 2 numbers that multiply to 12 that also add to 8, which are 6 and 2. So k plus 6 and k plus 2. So that one goes into those 2. Now it's always k to the 1st for all 4 of those, so that's as far as we can take those. Okay, so that is factoring by grouping for that one. All right, I think we're going to stop there for today. Hopefully that all makes sense to you. If you do have any questions, please make sure you reach out to me so that we can go over those together. All right, have a great day and pie out.